Hey, what's going on, guys? Let's do this problem right here. Let's evaluate whether this alternating series converge or diverge. The first thing we have to do is we have to pick up the b value. So everything except this negative 1 power is going to be the b value, right? So this is going to be our bn value. So bn is equal to ln n over n. In order to prove this one converges, we have to know it has to satisfy two conditions. First, this one has to be decreasing, and this one, the limit of this one should be 0, right? So let's go ahead and find the limits first. You can do decreasing or limits, you can do whichever you want first. So let's go ahead and find the limits and see whether we get 0. So if I take the limit for this one, limit n approaches infinity, ln n over n, right? And if you apply infinity for the n value, you will get infinity on top and infinity on bottom. So we are getting infinity over infinity, right? So here what we can do, we can use the L'Hopital rule. So let's go ahead and use the L'Hopital rule right here. So if we do the L'Hopital rule, this is going to be limit n approaches infinity, and we are going to take the derivative. Derivative of ln n is going to be 1 over. So let's say this is x or n. You can give it as n also. So derivative of ln n is going to be 1 over n, and over derivative for n is going to be 1. So this is 1 over n over 1. So this n goes to the bottom, and if you apply infinity, this is going to be 0. So this satisfies one of the convergent situation, one of the convergent condition. Let's look at the other convergent condition, that is, it should be decreasing, right? If this satisfies both of the condition, it's convergent. If it's failed to satisfy one of them, it's going to be divergent. So let's see whether it is decreasing. To find whether it is decreasing, what we can do, sometimes we can directly say, if it's just 1 over n, we know that as the denominator increases, the value is going to be less and less. So we know we can directly say this is decreasing. But whenever we have some complicated situation like this, we can take the first derivative, and if we get the negative values, that means it's decreasing, right? So let's go ahead and find the first derivative of this one and see whether we are getting negative values. So here what I'm going to do, take the first derivative, f prime x. So this is our function, f prime x of this one is going to be 1 over. So here what we can do, we can use the quotient rule, right? If I take the quotient rule, it's going to be denominator square, and then derivative of the numerator times the denominator, that's going to be 1 over n. So before I take the derivative, to avoid confusion, I write the function first, right? So our function is f of x is equal to ln n over n. So here we are trying to find the derivative of this one. F prime x is going to be, I'm using quotient rule. So here we are going to square the denominator, and first we get the derivative of this one numerator multiplied by denominator minus derivative of denominator multiplied by numerator. So that's going to be the quotient rule. So let's do that one right here. This is going to be n square, and derivative of numerator is going to be 1 over n, right? 1 over n times denominator, that's n, minus numerator times derivative of denominator, that's going to be ln n times derivative of denominator, it was n, right? So derivative of this one is going to be just 1, so it doesn't change anything. So here we are going to get, if we continue this one right here, so maybe let's choose a different color. So the derivative of this one is going to be 1 minus ln n over n square, right? So now what we do to find the critical points, we equate this one to 0. So if we equate this one to 0, denominator is like, let's say 0 is equal to 1 minus log n over n square. So here if you multiply n square by 0, that's going to be 0. So we can just say 1 minus log n is equal to 0. And then from this one we can say 1 is equal to log n. Therefore we can say n is equal to e. Right? So e is the critical points. So here E is critical points. Let's draw that graph. Let's check the values. So here we have E, and then as we know that E, if log E is going to be 1, log E is going to be 1. After that E value is going to be negative value, because 1 minus bigger value, that's going to give us negative value. So after this E value, this decreasing, right? So it not necessarily have to start with 1. We know this function is this notation is starting from 1, but if it's starting from any point and decreasing, because E value is going to be something like 3 point something like that, right? So it not necessarily has to decreasing from 1. If it's decreasing from some point, it's considered as decreasing. So this is becoming 0, limit is 0 and decreasing. So it satisfies the both condition of convergence situation, right? So therefore we can go ahead and say this series is convergent series. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.